I am Andromeda, an emissary from a planet in the Andromeda galaxy, here to help human beings. So let me ask, who convinced you that you can turn a frozen desert with poison air into beachfront property by next quarter? If the promise sounds like a startup pitch, it's because parts of it are, but the physics reads like the terms and conditions nobody wants you to open. My thesis: the numbers say habitats now, terraforming maybe in epochs, and the reason you hear otherwise is incentives, not science. Terraforming isn't planting potatoes in a dome. It's changing the planet's whole environment until a human can step outside without a suit. Think, wrap a planet in a warm, thick blanket. Fill it with the right mix of gases and keep it there for ages. On Earth, your atmosphere presses down at about 1,013 millibars. On Mars, it's around 6. That's like trying to breathe at the top of a mountain that doesn't exist. Terraforming means multiplying that pressure by at least tens, warming the surface by dozens of degrees, adding oxygen, and keeping it from leaking away. This isn't interior decorating, it's planetary plumbing, heating, and long-term security, all at once. Start with pressure. If you vaporize every scrap of accessible CO2 in Mars's polar caps and regolith, how much air do you get? A 2018 paper in Nature Astronomy by Bruce Jakosky and Christopher Edwards found you top out around 0.02 bar, about 2% of Earth's sea level pressure, before you run out of gas to release. That's after you spend colossal energy to mine and heat the planet. And nitrogen? Mars's current N2 is roughly 2.7% of a very thin atmosphere, about 0.16 millibars. You need hundreds of millibars to make air your lungs recognize. There is no known nitrogen bonanza waiting to be tapped. You can't inflate a world with an empty tank. Mars gets about 43% of the sunlight Earth does. To thaw it, proposals stack greenhouse gases that trap heat, CO2 plus superpotent perfluorocarbons, PFCs, or use orbital mirrors to beam in extra light. Chris McKay and colleagues outlined PFC strategies in the 1990s. They work in models, but only if you build a chemical industry the size of a nation, on Mars, sustained for centuries. Mirrors? We're talking structures tens to hundreds of kilometers across, an aluminum sun that makes the ISS look like a paperclip. Even fans admit the energy and manufacturing are staggering. You're not warming a cottage. You're trying to heat a continent with a hairdryer. Suppose you do it anyway. Mars lacks a global magnetic field. The solar wind slams into the upper atmosphere and strips it away. NASA's MAVEN mission has measured this erosion since 2014. Peer-reviewed analyses estimate kilograms of atmosphere can be lost to space every second during solar events. Over geologic time, that's how Mars got this way. A 2017 NASA concept by Jim Green proposed a magnetic shield at Mars's L1 point to reduce stripping. A bold idea, not an engineering plan. Until you solve that shield at planetary scale, you're filling a leaky bathtub. Even if you build the sauna, space steals the steam. Breathable air means oxygen around 0.2 bar. On Earth, cyanobacteria in plants took hundreds of millions of years to do that. Could machines do it faster? NASA's MOXIE experiment, MIT NASA, 2021 to 2023, pulled oxygen from Martian CO2, about 122 grams total across runs. Great proof of concept. Now line that up against the trillions of tons you need. You'd require a power grid larger than many nations for centuries, plus a way to store oxygen without it reacting away with the crust. Biology helps, but photosynthesizers don't sprint on a freezing, high-radiation world with almost no nitrogen. Breathable Mars isn't coming in V2.0, it's a geologic-scale marathon. So why are you sold the weekend project version? Because hope is a business model. Grand visions move stock prices, sell launch contracts, justify budgets, inspire films, and help negotiate regulation. Will Terraform compresses risk into a slogan. The Steelman is real. Audacious goals attract talent, spin-off tech for Earth's climate, direct air capture, closed-loop farms, better batteries, and give you a backup nursery for life. The strongest counter is also real. A 2018 Nature Astronomy review says Mars lacks the volatiles. MAVEN data says you'll keep losing what you add. And every credible roadmap requires industrial scales and timescales far beyond a lifetime. Both can be true. The dream is catalytic. the timeline is scandalously misrepresented. The sales deck says decades. The ledger says epochs. There is a saner cousin to terraforming called paraterraforming: world houses, domed cities, underground lava tube habitats, pressurized, warm, shielded, built piece by piece. Think biodomes the size of stadiums, then towns, with nitrogen shipped in from the outer solar system in measured doses, not planet-wide gas bombs. Every gram of progress here, ISRU fuel from CO2 via Sabatier, scalable radiation shielding, recycling ecosystems, helps Earth immediately and keeps Mars dreams alive without lying about timelines. Build rooms people can live in before you promise them a planet. Here's the reveal. Physics didn't cancel your future on Mars. Marketing shortened it to fit a pitch. The strongest papers say Mars doesn't have enough stuff to terraform now. Nature Astronomy, 2018. The atmosphere you add keeps leaking. NASA Maven, 2015 to 2021. And the oxygen clock runs on eras, not election cycles. So point the ambition where it works. Para-terraform cities you can walk through in your lifetime. And let those industries teach you how to heal the only world already terraformed, Earth. Terraforming Mars isn't a century project. It's a civilizational, multi-millennia commitment with missing ingredients. So the honest first step is domes, not a planet-wide makeover. Build the room. The world can wait.